In question 4.1, we have to find the area of cross-section of the wire used for a resistor. Well, we know that resistance is resistivity times length over area. So area is equal to resistivity times length over resistance. The resistivity we're given as 4.2 times 10 to the minus 7 ohm meters. The length, well, we have 50 circumferences because we have 50 turns of wire. So that's 50. The circumference is pi d. So pi times the diameter of 8 mil, 8.0 times 10 to the minus 3. And we have a resistance of 0.25 times 10 to the 3 ohms. This gives an area of 2.1 times 10 to the minus 9 square meters. In 4.2, we're to determine whether a 0.36 watt resistor is sufficient power. Well, the maximum power, when the thermistor is 0 ohms, it means we'll have a PD of 9 volts across the resistor. And power is given by V squared over R. So we have 9 volts squared over a resistance of 0.25 times 10 to the 3. This gives a power of 0.32 watts required. Therefore, 0.36 watts is sufficient. For 4.3, we're to determine the value of R that the student should select. Well, for the 0.25 kilo ohm resistor, we can find the current, which would be V over R. This has got 4 volts over the resistance of 0.25 times 10 to the 3. Gives a current of 0.016 amps. That is the total resistance through the circuit. The current for the thermistor is then, it has 5 volts over 750 ohms, giving it a current of 0.0067 amps. Therefore, the current for the fixed resistor is going to be 16 milliamps minus our 6.7 milliamps, which gives 9.3 milliamps. Then we can find the resistance, voltage over current. It has a voltage of 5 volts and we want a current of 9.3 times 10 to the minus 3 amps, meaning we want 540 ohms. We're given the data to 2 significant figures, so we give our answer to 2 significant figures. In 4.4, we're to state and explain the effect on the output PD of raising the temperature of the thermistor. Well, the output PD will go down. The resistance of the thermistor has gone down and therefore the current through the circuit rises. This must mean a greater potential difference across the 0.25 kilo ohm resistor. This means a lower potential difference across the parallel combination